we have 1, 2, 3, 4, 5. 5 steps to solve optimization problems. Okay, first step is D. Okay, D, diagram. Draw a diagram and label the dimension of the diagram. The second step is E. E is write an equation. Create objective, whatever you want to maximize or minimize. Okay, the third is express the equation as a function in a single variable, into one variable. D1 is differentiate to get f prime of x, and after that find the f prime of x when this one is equal to 0. Find stationary points. The last step is D2, or differentiate to get f double prime of x. Check whether this point is maximum or minimum. Okay. For this one, we use the acronym DEEDD. Okay, just remember D, draw diagram. EQ, okay, write equation, whatever you want to check whether maximize or minimize. EX, express into one single variable. D1 is differentiate the first derivative to find stationary point. D double prime is to check whether that point is maximum or minimum. Okay. Example, for a cylinder with a surface area 50, including the top and the bottom, find the ratio of height to the base radius that maximize the volume. So given surface area, okay, and this is the cylinder. Surface area is 50, including top and bottom. Find the ratio of height to base radius. So ratio of height to base. Okay, let's say this is H, this is R. Ratio between H and R that maximize the volume. V max. D then. First D is draw a diagram. So given is cylinder. This is the pattern of the cylinder. Okay, this one consists of R, label right R and H. Okay, and now we're going to find ratio between H and R. Okay, the next step is given surface. Surface is 50. Okay, find H ratio H and R when V max. Okay, the second is EQ. Find the equation for the cylinder. The equation is volume. V is equal to pi R squared H. Okay, let's settle. Okay, and the next step is EX. Express this one into single variable. Okay, from this here, this is R and H. Okay, before differentiate, we need to reduce to one variable. Okay, either you get rid of H or R. So, okay, find the info that relate to these two variables. Okay, so here S. Given S is equal to 50. Okay, so from here, find a relation between R and H. Okay, from this one. So formula for S, surface is S is equal to 2 pi RH plus 2 pi R squared. Okay, so because of this one is surface for the cylinder. Okay, this is cylinder, and then this part is refer to the area for this top and bottom. Okay, and this part one refer to the this area, this rectangular area. Okay, and this is 2 pi r h, 2 pi r perimeter of the sphere circle and h. Okay, so this is total surface is total for this area. Okay, and then given the s is 50, equal to 2 pi r h plus 2 pi r square. Okay, now here if you check, okay, study the variable. This variable is h and r, right? Okay, got only h here and h here. Later write h in terms of r and we try to get rid of variable h. Okay, so take h as a subject. 2 pi r h is equal to 50 minus 2 pi r square. H is equal to 25 minus pi r square over pi r. We now substitute this one to this. Okay. Okay, now V is equal to pi r square and H 25 minus pi r square over pi r. Okay, before you proceed, make sure simplify to the simplest form. Okay, and expand. Okay, and cancel this one. Okay, we cancel. Okay, we cancel. So it's r. R times 25 r minus pi r cube. So V is equal to 25 r minus pi r cube and settle for EX. The next step is to find E1, differentiate this V with respect to the variable r. Okay, and dV dr is equal to 25 minus 3 pi r square. Okay, then to find the stationary point or V maximum implies that dV dr is equal to 0. So everything here equal to 0. And then, okay, 25 minus 3 pi r square is equal to 0. Okay, r square is equal to 25 minus over 3 pi. Or r is equal to 5 over 3 pi. And r always positive. Why? Because of r is radius. Okay. And then this is the value for r when V maximum. Okay, now we have to check whether is it confirmed when r is equal to this value, the V is maximum. Okay, and then next step is find D double prime or D2. Okay, so differentiate again this part. Differentiate to find D2V dx dr square, D2V dr square. So negative 6 pi r. And substitute, okay, negative 6 pi 5 over 3 over pi, and the answer suppose negative. Okay, be negative, and the answer is less than 0. When less than 0 means the interval is maximum. Okay. Also now r is equal to 5 over 3 pi. Going to find h. H is 25 minus pi r square. Okay, 25 minus pi r square over pi r. Substitute r to find h. Substitute r this value into this r and r. Okay, so 25 minus pi 5 over 3 pi square over pi times 5 over 3 pi. Okay, simplify. 25 here is pi, cancel, can we cancel? Minus 25 over 3 over 5 pi. Okay, 5 third pi over 3. Okay, this one cancel, huh? The next step, 15 over 3 times, okay, third 3 over 5 third pi. Okay, this one actually equity denominator and okay, simplify. Okay, this one is C over D. Okay, this one is A, B, D, C. Okay, simplify. And this one is cancel 10 over third 3. So third 3 pi. Okay, and this is H. Now, okay, find the ratio between H over R is equal to 10 over third 3 pi over, okay, 5 over third 3 pi. So this is, okay, value for H, okay, and value for R, this one R, okay, R, okay, over to find the ratio and simplify. It's equal to 10 over third 3 pi times third 3 pi over 5. Same one, use this one, A, B, D, C. Okay, and simplify, cancel, can be cancel, and so it's equal to, okay, it's equal to 2. Okay, so H ratio R is equal to 1. Therefore, the maximum volume is achievable with a height to radius of H over R is equal to 2. Okay, so this is the answer for this question. Okay, so to solve this optimization problem, just remember either the first D is draw a diagram, EQ is write an equation for quantity whose maximum and minimum, EX express the quantity to single variable, E1 differentiate the first derivative to find stationary point, E2 is to find the second derivative to check whether the stationary point is maximum or minimum. Just remember did when to solve problem, optimization problem. Okay.